So, good afternoon everyone. I am Aarav Shrestha from grade 10 and today we are going to be discovering what are the changes in the gravitational force when we make some changes to the mass of the bodies and also make some changes to the distance between the two bodies. So, from Newton's universal law of gravitation, we have a formula that is presented on the screen over here. So, to calculate the gravitational force between these two bodies, it is, let's say the force is F1. So, the F1 is equal to G times the product of the mass of these two bodies, G times M1 into M1 by the square of the distance between the two bodies. So, that is R1 square. So, now we have made some changes to both the bodies. So, as we can see, we have doubled both the mass of the bodies, whereas again we have half the distance between the centers of these two bodies. So again, for the gravitational force between these two bodies, we have a formula. So again, this time F2 is equal to G times M2 into small m2 by R2 square. So now we can write this as, we can write m2 as twice as m1 as we have doubled the mass, and we can again write small m2 as twice small m1. And now since R2 is half of R1, we can write this as 1 by 2 times R1 whole square. So now this is 4 times G m1 times small m1 by 1 by 4 times R1 square. That is 16 times G times m1 times small m1 by R1 square. So from our previous equation, we have that F1 is equal to G times m1 into m1 by R1 square. So we can write this as 16 times F1. So we can conclude that when we double the mass of two bodies and half the distance between their centers, the gravitational force increases by 16 times. That is, F2 is equal to 16 times F1. So we can conclude that when we double the mass of both the bodies and half the distance between the centers, the gravitational force increases by 16 times. Thank you.